Hello students, welcome back to e-learning edu. So in today's class we'll be solving example 6.7 from the chapter haloalkanes and haloarenes. So the question is predict the order of reactivity of the following compounds in SN1 and SN2 reaction. The 4 isomeric first under that first sub question is the 4 isomeric bromobutane. Second one, the different structural formula is given, so we'll solve it later. So now let us solve the first question, the 4 isomeric bromobutane. So first of all, we need to understand the term bromobutane, right? So bromo means there will be only one bromine, and but means 4 carbon atom will be present, and ane means it will be having single bond. So each carbon atom will be having the single bond, right? So here let us solve the first question. So first of all, let us try the 4 isomeric bromobutane. So bromobutane means 4 carbon will be there. So this is a bromobutane 1, 2, 3, 4, 4 carbon and 2 1 and will be attaching the bromine. So other will be we can just occupied with the hydrogen atom. So it will be bromobutane. So now let us write the structural formula CH3. See, that's what I have written, CH3, CH2, 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 Br. Clear, right? How to write the structure. And after that, the second one, the second isomer is the same molecular formula. So here the difference is that bromine I am placing here in the second position. Okay, the bromine have placed in the second position. The first it was in here. So CH3, CH2, the structural formula C, CH3, CH2, CHBr, CH3. Okay, and next is the third isomer CH3, CH3, CHHBr. So here have placed CH3 in this position. Okay, so CH3 and when I write the structure formula, it will be like this. CH3, how many CH3 is that? 2. So CH3 twice. Then after that CH2Br. Okay, and again CH3, CH3, then Br. So how many CH3 is there? Total 3. CH3 thrice CBr. So that is the structural formula. So here the question is among the 4 isomers in the bromobutane, butane following compound in SN1 and SN2. Yeah. So here which one is more? Predict the order. We have to predict the order of reactivity, that is for both SN1 as well as SN2 mechanism. So I hope you are well aware of the SN1 as well as the SN2 mechanism, right? SN1 is substitution nucleophilic unimolecular reaction, and SN2 is a substitution nucleophilic bimolecular reaction. For substitution nucleophilic unimolecular reaction, the order of the reactivity is like primary. See here, as for SN1 reaction, the order of reaction is tertiary is more reactive than the secondary, which is more reactive than the primary. But for the SN2 reaction, it will be primary is more reactive than the secondary, which is more reactive than the tertiary. So in order to check for the order of reaction, first we need to classify which is of the first order and which is of the second order reaction. Okay, sorry, second order. So let us see here. Let us take it one by one. So the first one, see here, whether it is primary or secondary, the bromine atom is attached to the carbon CH2, which is again attached to the primary, that is only one carbon, hence it is primary carbon. For in the case of secondary, this bromine is attached to the 2 other carbon atom, right? Here one carbon atom is there and here one more carbon atom is there. So it is a secondary carbon atom. In the third one, bromine is attached to a single carbon atom. So here it is a primary. In the D, it will be like this. Bromine is attached to how many carbon? See here, see this one, bromine, this carbon is bromine is attached to this carbon is in turn attached to 3 other carbon atom, so it will be tertiary. So this is the this is how we classify, and after that let us see which is more stable. So for the SN2 reaction, it will be like primary is more stable than the secondary, which is more stable than the tertiary. Now let us see which is primary, secondary and tertiary. So we have classified that, and you know this first one, A is primary, then which one is primary? C is also primary. So let us see among this A and C which is more stable. So you already know the more the bulkier group, lesser will be the order of the reaction or lesser will be the reactivity, right? So here in the first example it is a simple chain and there will be less steric hindrance, whereas in the case of the C, here we can see the C, bromine is attached to the carbon and this carbon is instead attached to the two other carbon atoms. So the more bulkier group is present and the more will be the steric hindrance, so this will be less reactive. So the first one is more reactive, so A is greater than C. Again we'll write the secondary, with the secondary is this one, right? So this one is the secondary, B, which is greater than D. So this is how the order of reactivity: A is greater than C is greater than B is greater than D. So once you are thorough with the SN2 mechanism, the SN1 mechanism will be just the opposite of the SN2 mechanism, because in the SN2 mechanism the order of reactivity is tertiary is more reactive than the secondary, which is more reactive than the primary. Okay, so we can write the ulta or the opposite of the SN2 mechanism. So it will be D is more than the B is then B is more than C, which is more than the A. So I hope you are clear and very much thorough with this example, how I have solved this example. So please like, share and just subscribe my channel. Thank you.